So thanks everyone for coming to my talk. I will be talking about something what I'm really passionate about. And I've been working with this for the last at least 3 years, sometimes more, sometimes less, different technologies. But this talk is about Terraform, which I've been using for exactly 3 years. So my name is Anton Babenko. I am having a lot of fun working with open source communities and making my best efforts into adoption of Terraform and AWS. So I'm actively contributing and maintaining Terraform AWS modules, which were downloaded more than 1 million of times during the last 8 months. I will talk about this in details, what is it. And I also contribute to different Terraform projects, which all of them hosted in open source on my account. Modules TF is one of my projects which I started quite recently to see if there is a need for people to actually convert the diagram from visual diagram into infrastructure as code, which they can use. So I'm going to open source this approximately in 2 weeks. And if you have questions after the talk or any time during the talk, never hesitate to tweet or to send me an email. I always reply to emails. And in my spare time, I organize different events related to Corp user group, AWS, DevOps Norway, and DevOps Days in Oslo. And by the way, DevOps Days in Oslo is 2 days event, and call for papers is open. So if you want to visit Oslo one more time and have something to say, don't hesitate to submit paper. So the agenda of this talk is going to be that first we'll look into what is infrastructure as code, just from the top level, what is Terraform, and how typical CICD pipeline may look like, and where Terraform can be used, and what are the challenges there. So if you're doing DevOps today, you are probably doing infrastructure as code. So Jesse Robbins, who is founder of Chess, told it quite clearly that enable of reconstruction of the business from nothing but the source code and backup and bare metal, that's the definition. So why it is so important, actually, is that you can definitely treat infrastructure exactly the same way as code, apply exactly the same principles as you've been doing for the code. And more importantly is that you can validate that infrastructure changes are going to be exactly what you expect. And you know what's going to be changed. So this is how a typical multi-tier infrastructure looks like. So this is traditional website with load balancer, CloudFront, which is content delivery network, S3 bucket to store some static resources, couple levels of auto-scaling groups, and relational database servers. All this can be created visually, or you can visualize it using any other tools. But how to actually make infrastructure based on this nice drawing is sometimes hard. So in this talk, I will be talking about a tool called Terraform. And I want to know who can raise hands and say that they're using Terraform in production or know what is it about. So it just helped me to figure out who is the audience. Who used Terraform in production? Right, so a couple hands, that's good. So for those who don't know what is Terraform, Terraform allows to describe infrastructure in text files with extension TF, which looks like this. So in this file, we describe what kind of AWS provider we want to use, in which region, what kind of resource we want to create. It is S3 bucket. And we want to get output, like which bucket was created. So we want to get an output as a string ID of S3 buckets. In order to get this infrastructure created, we first run Terraform init, which downloads some dependencies. And then we run Terraform apply to see what's going to be changed. So we can see that S3 bucket is going to be created. And then we confirm that that's what we want. and the bucket is being created. As you can see at the very end, the bucket, my bucket sysnail was created. So that's exactly the purpose of infrastructure. You describe it in text file, you see what's going to happen, and you get an output as bucket was created. That's it. You can do this procedure for all other resources, introduce dependencies, and so on. This is very well described in official documentation, and that's not the purpose of the talk. So CI/CD pipeline is really important as an indicator of bottlenecks which likely to occur. And as soon as you know what are the bottlenecks, then you can fix them. And doing this in automated fashion is, again, important. So typical CI/CD pipeline may look like this, where code is being pushed to your version control system, then code is built, some unit test run, integration test run, then developers and some other decision maker people review it, and this code is then deployed to some stage environment and some production environment if things go well. So this is a whole deployment pipeline. With infrastructure changes, it is similar. But how to get started with Terraform? So first you read documentation, you write some code, you run Terraform apply on your local machine. It works quite easy in the same way as I just showed with creation of S3 bucket. But it's not always like this because it works approximately 60% of the time. Deployment works every time. So then you figure out that changing your code in one file and actually multiplying the same resources, and if you need to create similar resources, you just have to copy-paste this multiple times. It doesn't make too much sense because you're literally duplicating code. And when you figure out that you're going to create infrastructure for resources which were already created by someone else, it is a smart way to actually look into registry where more than 400 modules are already hosted for common infrastructure and architectural patterns, like how to set up networking on AWS, or how to set up high availability elastic container cluster on AWS, or something else. There are more than 400 modules already there, maintained, some of them tested, some not. I personally maintain one of the biggest collection of these modules which are verified and trusted by lots of different customers worldwide and in Norway as well. So these are typical modules for virtual private or VPC, auto-scaling group, relational database service, and many other services which you are likely to use in your AWS project. So when it comes to CI/CD tools and what can be used, for application we typically use Jenkins, Travis, Circle CI. Lots of different options are available. And when we are talking about Terraform, there are exactly the same tools available. So you essentially have to run these commands somewhere. There are still plugins which some people find beneficial because they wrap some output from Terraform or provide some input to Terraform. So there are plugins existing for Concourse, Drone, some integrations with Ansible, some integration with Jenkins, but Bash is the king still. You have to write a lot of Bash around it, and that's inevitable. Another tool which is made specifically for Terraform, which is going to be shining soon, I think, or I hope. The tool was made by people who were using Terraform in pretty big setup, about 100 different developers, lots of projects, lots of environments, and people wanted to get confidence how this change will actually be applied in production. Like, can I guarantee that this change will not break something? So Atlantis gives you a unified workflow through pull request. So you open pull request, you commit some Terraform changes there, and you allow Terraform to be executed by Atlantis, and you can see output. So you don't have to distribute credentials to your AWS environments to individual developers and give them access to production, like to everyone, just to be able to do their changes. Atlantis does it for you. In HashiCorp, there is a product for people who are friendly with enterprise. They find this very great tool because it allows you to run traditional Terraform operations from graphical user interface. They have their own private modules registry, which allows to share Terraform modules between developers and different teams and see what kind of modules are used across the whole organization. It's all good and it's all great, and I highly recommend to use it, with only one exception, that it has enterprise pricing. So take it with kind of enterprise is keyword here. So I don't really know how much they will ask you if you approach them, but I have not met any single customer who's using it in production. So as a pre-summary, we saw how Terraform code can be written on developer's machine, how it looks like to create small things like S3 bucket, what are CICD options are there, and specifically for Terraform. And there are a few gotchas about implementing Terraform in CI/CD pipeline. For example, when working with centralized system like where Terraform code is executed, the only option where Terraform state is JSON file which contains information about resources which were created by Terraform. So there are a few options with it. One is local state, where you save this file on the machine where it was run, or remote state, where you save it outside of developer's machine. And the remote state option is the only option for such setups. Also, Terraform is being a new project, and it has a lot of things which you have to practice and see how it works and why it doesn't work. So error handling is one of that scenario where the best solution is to actually retry it one more time, retry it again, and see that problem will be fixed. The reason for that is that Terraform does not roll back when there were an error. So Terraform planned what's going to be changed. It planned the whole graph of execution. So it knows this resource first, then output from this resource should be passed to another resource as parameter, and so on. So if there were some delays or some inconsistencies, because it's often eventual consistency, so eventually it will be consistent, but you better try it one more time. And also, as a solution, is to force Terraform to execute not more than one parallel execution, while Terraform always try to execute the whole graph of changes as fast as possible. So if you're creating resources which are not connected between themselves in any way, then Terraform will issue several requests at once, up to 6 by default, and they will be executed. And detailed exit code can be very helpful if you need to know what exactly is going to be changed and whether it is changed or whether it's an error. So when having Terraform running on central place like Atlantis or CI server, it's important that the content of .terraform directory, which is temporary, is shared between execution, so that each executor doesn't have new copy of something what may be mismatching. It's often when people are using code which is publicly available, but they just fork it and keep their own fork themselves inside their organization, so that they don't have to be afraid that somebody pushed something unstable and their code breaks, or somebody delete the whole repository and then my project is gone completely. The important thing is that if you are forking private GitHub repository and then owner of this private GitHub repository decide to delete him, your fork is also gone. That's sometimes a big surprise for people because they think that if they are forking something private, then it will be there forever. No, it's not. That's I mean, I was in a situation where this was kind of crisis once, so that's why people sometimes tend to fork it on the CI server, maintain their copy completely isolated from GitHub. So when it comes to secret, it's naturally part of CI system using environment variables or some other things. In Terraform, secrets will eventually be stored in a state file, which is, again, JSON file. So it means that if you have full access to this state file, you can get secrets in plain text. In some situations, it is possible to use PGP or keybase to make sure that if it is IAM access key, which is a very important key to get access to AWS API, then it will be encrypted. And RDS is also having some features. The important thing, which is hopefully going to come later this year, is that the implementation of secret is not going to be part of providers themselves, but it's going to be implemented as level up in Terraform Core, which is much better, so that you can simply say that, yes, please encrypt this stuff. It doesn't matter if providers support it or not. So if you look in this specific, very teeny example of resource which generate random password, and I want this password to be random, I keep my Terraform state file secret. It is on S3 bucket, which no one has access to. I'm very happy. The only thing which people can access is my CI, hosted CI tool, where it's not a big problem. They can look into what I'm working on, but they will not see the password because it's here. I'm not outputting password. So yes, in fact, when you run Terraform apply, you're not outputting password, but Terraform does it for you. So be careful when you see a random string, and it will be outputted, as in this example, ID, JQ, less, minus, less. This is password, which was generated by Terraform. In some cases, it can be a problem if you render something and too many people have access, then they have password here. So quite obvious is that just don't deal with passwords. It's pretty easy. The access control principles, which were described many times in many different security-related papers, and in particular this one I took from AWS documentation. Yes, grant only the permissions required to perform a task, which is common sense. But in terms of Terraform, if you're working on developer machine, it's likely that you have full access or admin access to the whole infrastructure. For some small setups, it may be good. For big setups where you have lots of developers, the best approach, which I can recommend, is that you actually use different types of access key and different types of roles. So you, as a user, may have access to two different AWS IAM roles. One is read-only, and another is admin role, which allows to do destroy and change operations. Terraform has several commands which which is enough to use just read-only roles, which is init, refresh, validate, plan, which means that you will never touch resources and you will never change anything there. That's, in most situations, enough. So this is something what you can safely give to developers if they need to just plan something to see what's going to happen, to validate that syntax is correct, and so on. But if your CICD tool is actually doing something more, then it's better to use multi-factor authentication in order to assume admin role. So access control is one thing, and in some situations you may also think that when developers submit code for the review, you think that that's exactly what he wants. Usually it's not always the case. sometimes he has to have some more like opinions, some more discussions. And Capital One has a tool to simplify pull request approval and make more sophisticated rules, like who has to be able to say that this is good code and who should not say that this is bad code. So you count ++1 and -1 and then see, based on complicated rule, that this code is actually correct. For those who worked with Gerrit, this is a similar thing. And it's heavily dependent on how you structure your code. So there will be some information about this. So Terraform design patterns is related to how you structure your code. If reading documentation on Terraform website, you may think that it's okay to create just resources individually. Then you figure out that it's better to group them by modules. And if you think more about this, then you can think about what kind of modules are there. So resource modules, infrastructure modules, and compositions. These three big concepts, or big patterns, I would say, which helps us to make really reusable infrastructure as code. So resource modules' job is only to create resources. They're flexible, they have no relations to anything else, and they support versioning. That's the main idea of resource modules. Most of Terraform AWS modules, which I maintain, are exactly these kind of things. So it's very hard to make something new in VPC, and it's unlikely that you need to maintain your own VPC module because it simply has all possibilities already. If it doesn't have people contribute code and we maintain it. It has about 200 of stars right now and lots of pull request issues and discussions. So it's pretty active projects on Terraform AWS modules. Another side is Terraform infrastructure modules. The difference is that this is like parent for resource modules. They often enforce company-wide standards like tagging, names. They may fulfill missing features of Terraform by using JSONnet to generate some pieces of code or cookie cutter to generate some more complicated structure. And they always version according to some schema. Semantic versioning is not always good, but versioning it by date, months, or year, months, and date is often good because it gives you an indication when this module was last released. Composition on another side is parent from infrastructure and resource modules. So it is something what describes the whole infrastructure which is valid for the whole region or for the whole environment or for the whole project or module. Module is probably a bad word here, but project, region, AWS account, something more global. And TerraGrant, I will not go about this, but TerraGrant, you can search about it, is a tool to describe composition in a very nice way. So basic pipeline for the code looks like this. And when I say for the code, you can replace word code. For infrastructure code, application code, it has to look exactly the same. There is no reason. So you say that you're going to work on new features. So you make a branch, you commit code to this branch, you push this branch, you open pull request, then people review this code, and once it's approved, then this branch is merged into master, and we just run Terraform apply in the master branch, and we have this change implemented. So for infrastructure again, and for application, it should be exactly the same. Of course, the last step is different for application. So it looks something like this. This is an example of how pipeline looked for Circle CI. Circle CI is just managed service, which allows to describe workflows. It is synonym of pipeline, and it has certain steps. It has possibility to run it in parallel or sequentially, and it has step called approval, so that before applying infrastructure, you can actually see this yourself and say, yes, that's I want, so then it applies. So it's one of many, many tools. So pipeline for modules can look a little bit differently, because module essentially is something what you share in the organization, and it should be able to do something what you don't want your users or users of your modules to do. For example, you often have to implement some missing features of Terraform just there, and don't let your developers who don't know what is Terraform, for example, to be scared by this. So just hide this away from them. And way to run a test on modules is there are different providers and different tools. This is very new area. A lot of people are doing it just by comparing plan of the module and see what kind of resources are going to be created, and that's what they want. Another type of this is to actually spin up the whole infrastructure based on fixtures which were provided by the module, and then ask a provider, which is AWS provider or Google Cloud provider, and ask if this instance or if this resource was actually created, and then compare these answers. There are a few tools which I want to share with you. So some of them are very helpful to make sure that your code which you are writing is actually correct before applying it, and looks for formatting and looks for very easy to catch errors. For example, if you're specifying wrong argument, for example, you specify security group which does not exist. So tflint will be able to tell you and will be able to say this before you actually run Terraform apply and Terraform apply and see, oh, it doesn't exist. So it's very good idea to execute this early on. Also, it can tell you that you are referring, let's say, instance type which does not exist or something like this. Terraform docs is another tool which allows to generate Terraform modules documentation by getting information about variables and outputs, which is very good idea if you make a module and want it to be shareable, so people have to understand what kind of inputs and what kind of outputs modules accept. So when we're talking about infrastructure as code, we think that, yes, let's automate everything, put everything in pipeline, it will work nicely. It's not always like this, because, of course, there are a lot of things which we cannot do with pipelines. Even if they look good and work usually much, much better for application code, there are a lot of things which we have to do outside of pipeline manually. Things like refactoring or upgrading versions of different dependencies, or if we discover some rollback, or if somebody, quite often happen, somebody execute Terraform apply on his laptop and didn't want to wait forever, so he just closed laptop and go home, then it means that infrastructure is locked and you cannot do changes, so you have to force unlock it. This happens quite often when people don't think that it's actually working from your machine. So it's important that you have connections open. You have to make sure that it's still on until it finishes. So there are a lot of Terraform problems which I was experiencing myself, and a lot of them which I got from different sources like Reddit and Stack Overflow and emails as well. Sometimes people send me a piece of code which I would never think that people can run, but yeah, it works. So refactoring is actually adding new feature or moving one module to another place or renaming something. The definition of refactoring, which I like most, is that refactoring is making incremental changes into the infrastructure or into the code, which brings you to the desired state, closer and closer. So normally refactoring has to be small, like incremental, and you have to accept some temporary ugliness, but the end goal is to have code properly structured. And Terraform state MV is one of the most powerful commands, which allows to move definition or configuration of resource between different modules, or it can allow to rename resources. And also, if you have lots of different modules in one project, you may have to have some need to update versions of all of them. For example, you want to run latest version of your modules, and so on. So probably for the name, I decided to start, I used Ansible before, and I used Terraform as well. So I just decided to combine this into one tool called Terrible. And yeah, it works for me, mainly because I can write commands like make terrible plan or make terrible update. And then it goes recursively in all projects where Terraform was found and do something for it. So Ansible turned out to be not the best tool for working with files and updating some files and running things sequentially. It is extremely complicated, and I'm really glad that I pick up Ansible for the name. That's it. So Terraform upgrade is a very tricky part of it. When new version of Terraform comes up and you start using it, you don't really know that it will work 100% for your infrastructure or not. It's very often that there is small bug which will be revealed after 2-3 days of usage in some small use case, in some strange situation. The thing is that when you start, now it's not so big problem anymore because release cycle is every 3 months, and if you are not willing to use the latest version, it's okay. You can wait for 2 weeks after release when another version will be released with more fixes. But if you are in a situation where new version has been rolled out, your developers start making changes into your infrastructure and apply these changes. The state file contains meta information which says which version of Terraform was used. And this meta information is verified every time when you try to run Terraform on new machine. If state file was updated with the latest version of Terraform later than the one which you have on your machine, it will not let you execute it. It will say that, oh, this file was modified with newest version, so you have to update it. And you figure out that this version is not the one which I want, so I want to roll back. Rollback means that you have to download previous version of your state file from S3 bucket and tell Terraform to use that one instead, because you want to stick to the previous version until the bug is fixed. So this specific 3 commands: download previous version from S3 bucket and push it by overwriting existing state file. This is a pretty scary command to do if you have a lot of state files, or if you have one big state file where lots of developers are managing. So one thing related to Terraform upgrade, which I really recommend, is to have a lot of small files where you change small things. You have very few resources in these files. And then when you run into trouble like this, it will be much easier to revert just small subset of resources. So Terraform logs is happening when developer close his laptop during execution and go home. So then the rest of the team has to do something. Luckily, there is command to do a force unlock. And as I mentioned earlier, there is a tool called Atlantis, which allows to run Terraform commands from pull requests. A couple weeks ago, I open source module for running Atlantis because I want people to actually use it to get confirmation for the changes which they're going to work to implement in Terraform is actually what they want. So I made this module and this Terraform configurations which you can run in, I don't know, in a couple minutes just by providing very few parameters and get production-ready Atlantis up and running. So Are there any questions before I show something else? No. Okay, then I will show something. Something is... So I want to show how this pipeline looks like. So can you see it? Yeah, you can see it. Good. So I'm using Circle CI to execute certain steps. So I'm executing steps to validate infrastructure, to plan infrastructure, and to apply infrastructure. I also ask for confirmation that things which are planned is actually what you want. So this syntax is part of Circle CI, and it doesn't have anything to do with Terraform itself. So the configuration for this example looks like this. So that starting from the top, I'm defining which version of AWS provider I want to use, and then I'm getting information about existing default VPC and default subnets or existing subnets. And then I'm going to create security group by invoking security group module. And then I'm going to create EC2 instance with this name and this instance type. So that's all what it does, nothing very special. What I wanted to show is that this code can be executed in multiple different ways. So I put it in GitHub. Can you see the screen? Yeah. Okay. So yeah. So this main TF file is executed when you run Terraform. Actually, all TF files are combined, so you don't have to care about names of them. So all of them will be combined and resolved simultaneously. So in the example which I want to do is that if I run this Terraform init from my local, then it will download dependencies and it will see what has to be done. It says that everything is good and I have to be able to run Terraform plan and Terraform apply. So if I now run plan, so it says that instance has been created because I launched it before. And here we can see what the Terraform is telling what exactly is going to be changed in order to apply this configuration against existing AWS infrastructure which I ran previously. So it tells that this yellow lines means that information will be changed in place. But at the moment, Elastic IP is assigned to this instance. And it will get instance ID from this launched instance. The sequence in which commands will be executed in which order is up to Terraform to define. Terraform knows about this very well. It's very seldom when we have to tell it to actually do one thing before another. So this code will create EC2 instance of specified instance type with this name, and it will delete the previous one. So we can see that it has to add instance, then it has to change Elastic IP to assign it to the new instance, and it will destroy the old instance. So that's what I want. I can run this code here. That if I do this, it will again show me the plan, and it will ask me if that's what I want. Normally, if I'm single developer or if I don't have continuous integration pipeline around, that's what I would do. But in this case, I don't need to run it, so I can just say no or type anything else, because I don't want to run it from my local machine. This would be too boring. It works for my machine, works on my computer. That's too bad. Let's try to get it up and running from the CI, and imagine that there are many developers working on the same code. So the first thing is that I want to do a real change and see that really applied. So let's say I want to have instance type not T2 nano but T2 micro. So that's a real change which I want to make. So check out new EC2 type. Check out, yeah, I wrote it correct, but almost. So new So I'm trying to work exactly the same way as with code. So there are a couple pre-commit hooks which were executed on my code because I really don't like developers to talk about, hey, there should be spaces or here should be tabs. There is one canonical way to format Terraform code, which is called Terraform FMT. That's done. The configuration for this is in pre-commit config, where I'm invoking pre-commit hook called Terraform FMT, and that's what I want. I also want to make sure that there are no merge conflicts, so that is also verified. So this commit has happened, and I can now push new EC2. Cool, so now I'm making a pull request to the master branch. It's time to start text editor. Good idea. Yeah, time to download update. Excellent. Okay, so pull request has been created, and if I go there, I can see that this is exactly what I made, and now Circle CI has been triggered to run certain steps. So let's look into Circle CI. Circle CI is very, I would say, strange product because it was working for years in Chrome and stopped working in Chrome just a couple weeks ago. So that's the only reason why I use Safari. I think it is because they use approximately 12 social trackers just for fun. And the pipeline here looks like this. So the simplified way is that I run Terraform validate command on the first step, and then I run plan. So that's I can see that init was happening and validate command happened, and it says good. So everything was formatted correctly. So let's see. Steps like plan was executed, and I can explain that this is change which I wanted to do. Yes, in fact, that's it. T2 nano and T2 micro. Excellent. So as you can see, I made pull request, I work in branch, and I can see what Circle CI just reported, that green. So I was using Circle CI to work on feature branch. That's fine. This worked 100% well for application code. But with infrastructure changes, again, there is Atlantis. Atlantis would allow me to run this code right from this pull request, where I can just type Atlantis plan. And if I run Atlantis plan, and if I would provide efficient or sufficient credentials for it right now, then it would output in the right way what is the output of this command. So what it does is that it runs Terraform init, Terraform plan on the Fargate service, and output from there into this pull request. The reason why it is failing now is that this is a public repository. Literally everyone can go there and write Atlantis plan. Or one of the security holes, which is not fixed yet, but I'm working on it quite actively, is that if you commit your code, which literally echo AWS secret key and access key, you would get them. That's not what I want. So the way to do this is to use very short-lived temporary credentials, which are valid just for this plan. So you assume valid credentials for a very short time, not for time, but you explicitly revoke them at the end of execution of Atlantis. So you don't have 1 minute or 20 seconds. You have just how much Atlantis is running. And the correct output would look here like this. If that's what I want, then another command which I can run, Atlantis apply, and again, Atlantis is listening to GitHub webhook, and Atlantis would execute this code. Now it will fail by exactly the same reason, because I didn't give enough credentials to it. I'm working on it, and I think I will fix it during this week to make it actually usable for the public repositories. But developers of Atlantis are not recommending this, exactly for this reason, that you can steal credentials. So we'll see what happens. I try to work on it on very isolated environment without anything shared. So I hope nobody will submit Terraform code for mining Bitcoins. But nevertheless, it's a good idea. We can make Terraform modules for mining Bitcoins openly. So when we run Atlantis apply, it will fail because plan was executed, but plan was not approved. So now, as an approval of this code, imagine that you see a Terraform plan, and you say, yes, I approve this. So you have to actually click somewhere here, reviewers. There would be a name of somebody, and he says, yes, I approve it. So then it means that it's not possible to apply code, but it's possible to plan for everyone. There are some workarounds necessary to implement multi-factor authentication in order to apply changes in sensitive environments or with sensitive settings. But it's not part of Atlantis yet. So as you can see, this worked for pipeline in this worked for pipeline in pull request. Let's say if I merge this code now, there should be another type of pipeline which is executed. So now code is in master branch, which means that pipeline has started. So yes, this is view for the pipeline. And this pipeline has 2 more steps. So after the plan phase, it will ask for approval, and approval is valid for, I think, 1 day or maybe even several months, I don't remember, which means that you can take a look and see if that's what you want to apply, and you have to manually click here and say, yes, I want it. And if plan succeed, so plan should succeed. So then approval will be visible, and once I click apply, the changes are actually applied. So now it says on hold. It asks me to verify. Imagine that I check plan, and yes, that's I want, so I approve. And now from this phase, it goes to apply infrastructure phase. Approve. Almost. Right. So now it's applying changes, and it will be soon finished. So going back to a couple slides, which I have here. So as a final summary, CICD is good for automated things, but a lot of things are still necessary related to refactoring, upgrade, rollbacks, force unlock, are still better to be done by humans, especially refactoring. It's not like with code where you build some binary and that's it. When using minimum roles is important, then you have to use it, and MFA is used to deploy to production or do some destructive changes. So yeah, the question, if the first question is about stickers, then the answer is yes. And do you have any other questions? So yeah.
Do you do rollback by check out earlier commits? Is that how you do rollbacks?
So the question is, how do I do rollbacks? Rollbacks of the code?
For like a state for Terraform.
Yeah, so there are all things which I've been talking can be and should be possible to roll back. It can be version of Terraform, version of provider, state file, configurations, values, version of modules. So if everything is in code, then it means that just check out latest version of the code and run apply again on it. When it comes to state, then the best option which I normally do is that I simply check out that known state which was before, and just manually verify that there are no obsolete resources laying around. Having a lot of small states file simplify it very much. So I know that there are like 5 resources or 2 resources or 1 resource in one state file. That's very easy to verify, and you don't have to think too much about downloading previous version of this state file, applying it same way as I showed with S3 API calls. Yeah. Yeah.
How common is it to use test automation in the pipeline using those testing tools you mentioned?
Yeah, that's a great question about testing. So testing of infrastructure changes is so new that not even all providers are supporting it and taking it as a key concept. So for example, on my observation, there are a lot of people working with AWS and thinking about testing of infrastructure change and using Kitchen Terraform. So you write your own what is it, Ruby, yeah, no, in-spec code in Ruby. You define your different things which you want to test against. You run it and create infrastructure, and then take one by one if this instance had this tag or if this instance belonged to correct place. So it's very advanced. It has a lot of possibility. The only downside, you have to write it in Ruby, in-spec, a few other things have to be around. So I would say this is way complicated and very powerful. There are a few tools which came up recently for more general testing, like infrastructure testing framework called TerraSpec, which is a framework where certain steps are defined. You have to write it in Go. So this means that you first write your nice HCL code for Terraform. You then think that you have to execute this code, and you have to do certain assertion to verify that things were created in correct order. Which means that instead of using Ruby, you have to just write a lot of things in Go. Yes, there are a lot of helpers which simplify some of these things, but these things, so what TerraTest gives you is certain functions which, for example, connect to SSH instance or connect to from this instance to RDS instance. So they have lots of helpers. The biggest downside is that suddenly you have to teach people who are writing Terraform code that they have to write Go code. And this Go code is not very, I would say, developer-friendly or sysops-friendly. I mean, it's developer-friendly, right? It has all features of programming language, but it's not for sysops or for people who were affected with the idea that everything as code, you write lots of small, nice, beautiful code, but you have to put a lot of Go code on top of it. So my personal opinion on that is that it's easier and it has to be implemented in certain phases, is that you test things which you really care about. So you have to make sure that your infrastructure is created using certain policies, like instance was launched in this region. This can be verified by launching instance and checking where it was. So that's what Kitchen Terraform does. TerraTest is doing much bigger scope of this. It's not just testing where instance was launched, but it also helps you to test whether certain package was installed on this instance. And to my opinion, that's not job of Terraform at all. Terraform stops where user data starts, right? So when you have user data and installing a bunch of packages, use whatever else, but not Terraform. So there are also a few things which simplify adoption of Kitchen Terraform, which are allowing to generate tests based on state file, which is, for me, it seems very cool idea that first you create your infrastructure, so you know what kind of state is there. And then it just generates inspect controls for your infrastructure. So literally a lot of them for each thing which it knows about. And then just run it and you see that everything is good. So I think it's important that testing is actually making things easier and not testing for the sake of testing. Microsoft is doing slightly different with Azure. Their testing framework is, I would say, mocked in Docker containers. So they run Terraform on specific environment, and then they just say that if it was created, then it's good. So it's different types of. I have never seen anything related to Google, so I have no clue how Google people are testing their stuff. Maybe in production, because that's a place where traffic exists. So, any other questions? Yep.
Thank you for the speech. Have you got any idea of if Terraform are planning to let the user decide what to do if there's an error? Do we stick around and wait for and do it 100 times, or do we fail fast?
Right. So to clarify the question, from user perspective, what is the best way to handle this failures, right?
Yeah, because it may vary a lot between different applications, and it's impossible for HashiCorp to know.
Right. Okay. I think I got your question. Correct me if I'm wrong, but there are few things which can be wrong with execution of Terraform. Like historically, the most famous answer was to just restart, rerun it again, and in 90% of cases, problem was gone. This was a problem related with eventual consistency of certain services of certain providers. Now this problem, so this was even to the extreme that there were shell wrappers, and they still exist, shell wrappers which checks for output from Terraform. And if there is string which says that you see this error, then, oh yeah, just restart it again. So that was pretty funny to see execution of Terraform in a loop unless it meets this error. Normally, the way how Terraform handled this error is that you allow developer themselves to decide what to do. Terraform will unlikely to do, like not unlikely, but will never, I would say, do rollback, even if it can, because rollback essentially is the same operation as roll forward, but just roll back. So you have previous state, which you have physically in file. You have previous configurations, so just run. It should be easy, but Terraform will not do anything like that. So Terraform allows you to handle these errors yourself, and by splitting your code into something smaller, it should be not so often now. Yeah.
Okay, thanks.
So yeah, I think if you have any questions, don't hesitate to ask me anytime, anywhere. I'm Anton Babenko on almost all places where it's possible to be. And yeah, the code for the talk is here. So thanks. That's it.